Hello everyone. Today we're going to be learning about exponential regression, and I'm going to be showing you how to do that on the graphing calculator. All right, to start off with here we have some two variable data, and we need to enter that in our calculator. We are going to enter our x values in list 1 and our y values we're going to enter in list 2. And remember to do that on the calculator. You come over to the statistics button. Okay, it shows up red on, so you can see what I'm touching here. Also, we are going to choose this top edit button that's already highlighted. So we're going to hit enter. All right, I have actually, to save time for this video, already entered these into the calculator, but I want to make sure that you know how to do that. So we are on list 1, and you're going to just enter 0.1 and enter or arrow down and go through. You need to make very, very careful that where they line up here, 0.01 is with 1.1. You have to make sure that they're lined up here on the calculator. So go ahead and pause the video, enter your data, and then come back, and we're going to go through and double check. All right, so now we're going to go through and double check that we've entered this correctly. So let's just go through and check. 1 is with 1.4. 1 is with 1.4, 1.9 is with also with 1.4, and go through and go down and double check. And you can check yours carefully. I have done that here. All right. Okay, so we have our data entered. We want to look at what we've been doing, linear regression, so we can see the difference here. We have, when we find our linear regression, we come back to statistics. We want to calculate, so we arrow to calculate. We have been choosing option 4 right here. This is option 4, our linear regression. That's the one we've been choosing. So when we choose that, we arrow down or enter, 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 and then we have here our equation. It shows us here, it shows us our y equals ax plus b, and we're going to write that equation over here. This is our linear regression equation. So y equals, we're going to round to 2 decimal places. That will be 1.07x plus, and our b is negative, so we could have just done subtraction, but here's negative 0.698. So that rounds to 0.7. All right, our correlation coefficient, I'm going to remind you as well how we find that on this graphing calculator. You can come, there's a couple different ways. Today I'm going to show you where you hit the mode button, and we want to, if you'll look, we'll come down to arrow down to this stat diagnostics, and we want to toggle that over to on. So we're going to arrow down. Oh, I went too far. Up. We're going to come over to the on and hit enter. So now our stat diagnostic is on. We are going to go back to our statistics button. We're going to still look at our linear regression, what we've been doing. So come over to calculate, choose option 4, arrow down and hit enter. And here is our correlation coefficient, which is 0.9. We're going to round it to, you know what? This time I'm going to go farther, and I'll show you why in a little bit. I'm going to round it to 0.928. 0.928. We went 3 decimal places. And this is a positive and very strong correlation, okay? Very strong. So now we've been doing our linear. I'm going to show you the only difference here. We already have the data entered into the calculator, which is really nice. So we are now going to, and this is what our scatter plot looks like. And here's what that line, linear regression line would look like. And see how it's kind of the best line, linear, that would fit through that data according to what we've looked at so far. But what we're going to do now is we're going to look at exponential regression. So come back to our statistics button, and we want to still go to the right and calculate. But we want to now arrow down until we get to 7, 8, 9. We want to actually go to 0, or you could just type in 0. This is exponential. Let me mark it right here. This exponential regression. This is the option we are going to choose. So hit enter right there. Our X values are in our list 1. Our Y values are in our list 2. So we are going to arrow down and hit enter for calculate. And it gives us our exponential equation. Our exponential equation looks right here. It gives us the code. Y equals A times B. And that little caret, remember, is to put the X in the exponent. So Y equals, I'll just write it over down here as well. Y equals A times B with X in the exponent. Okay, so we're going to, it gave us our A and our B. So if we round to 2 decimal places, up here we already have our Y, we're going to put it right here. So our Y equals, A is 0.87. We're going to times that by our B is 1.33. 1.33. And the X is up in the exponent. So it's not being times by X. The X is actually in the exponent. This also gives us a correlation coefficient right here, our R. This is for our exponential regression. Our correlation coefficient is 0.981. If we went 3 places like we did before, 0.981. That is also a positive and very strong correlation. So let's look at that graph. So looking at that graph, which would be the line of best fit? Our linear with the straight line here, or our exponential with this curved line here? And as we can tell, the curved line fits this data better. So that's why we are learning here both, so we can see what we would want to use. So this question, which equation is the best to use to predict this data? Well, of course, we could tell that as even looking at that graph, that the exponential equation, now we need to write that down again on this page. Whoops. So we have our Y equals, we had our 0.87 was our A times, or we can just use the dot for times here, times our B was 1.33 to the X power. Now, how could we tell that that equation is the best one without looking at that graph? That graph showed us by looking that, yeah, the exponential one was better. But if we come back here and look at, this was our exponential correlation coefficient. And if we come back one farther, or 2 farther, here was our linear correlation coefficient. So which one is stronger? They're both very strong, but which one is even stronger? The one that's closer to the number 1 is the strongest, which over here, so here we have 0.928, and our exponential one we figured out was 0.981. And 0.981 is strong. Oh, before I finish, you'll probably be asked on your assignment, what would be the data? They'll give you something for the X and you will plug it in. So you would have Y equals 0.87 times 1 to the 33. And on a certain situation, you'll say maybe when X is 3. So we would actually type that in our calculator. We'll practice one of those real quick. So over here on the calculator, if we want to go back to the main page where you do calculations, remember you hit second and quit. Let me erase these right here. All right, we are going to use the calculator to type in this equation right here using 3 as our X. So we are going to type 0.87 times 1.33. And remember the little caret up here that's underneath the clear button is how we raise and put our 3 in our exponent and hit enter. So our answer for this would be if we went to 2 decimal places, it would be 2.05 be our y when our x is 3. All right, have a great day.